Alright guys, here we go with lesson 10.8, which will be the last lesson before your next test. So in previous lessons we had discussed simple probability, where we were looking for the probability that one thing would happen. In this lesson we're going to be talking about the probability of a compound event. So a compound event is where it consists of two or more simple events happening. So we're going to take those simple probabilities and we want more than one of them to happen. So the first thing we're going to discuss is finding out how many different possibilities there are. So we could make a table, we can make a tree diagram, or we can make an organized list of all the possible outcomes. So we're going to do an example of each of them. In this first one, a pet store sells aquariums in 3 shapes: hexagon, pentagon, and rectangle, and 2 sizes, 10-gallon and 20-gallon. How many different fish tanks can be made from the different shapes and sizes? So for this one, we're going to make a quick table. If I go back up here, I know I have 3 shapes. We have a hexagon, pentagon, and rectangle. And then we have the 10-gallon and 20-gallon size of each of them. So for my table, I'm going to label it 10-gallon and 20-gallon. Then under each of them, so for my 10-gallon tank, it could come in the shape of a hexagon, a pentagon, or a rectangle. Same thing for the 20-gallon, so we could have a 20-gallon hexagon, a 20-gallon pentagon, or a 20-gallon rectangular tank. Okay, so from here, there's 3 options under each size, so that tells me there are 6 different tanks. And again, we have listed on our table what all the different tanks are. Okay, so there's an example using a quick table. For our next one, students are assigned a temporary password the first time they visit the computer lab. Temporary passwords consist of a letter A, B, or C, followed by a number 1 or 2, followed by a letter X, Y, or Z. How many different temporary passwords are there? Okay, so for this guy, I'm going to make an organized list. Now it's important if you're making a list that you make it organized so that you don't accidentally miss anything. So if I go back through here, highlight my options just like we did last time. So we start with A, B, or C, followed by 1 or 2, and then finish it off with X, Y, or Z. So starting with my A options. So we can start with A, and then 1, and then an X. We could get an A1Y or an A1Z. Okay, now if I'm sticking with my A, we could have an A followed by a 2 and then an X, an A2Y, and then an A2Z. Okay, now we're going to follow this pattern. We're going to move on to starting it off with a B. So starting my password with a B and a 1 options first, so B1X, B1Y, and B1Z. And then sticking with the B, but now followed by a 2, so B2X, B2Y, and B2Z. And last but not least, we've got our C options. So following that same pattern, so C followed by a 1 and then an X, C1Y, and C1Z, and then a C followed by a 2, and then X, C2Y, and C2Z. Now that wasn't too bad, but you can see how if we weren't organized and we're just kind of willy-nilly picking our letters, numbers, and then the X, Y, or Z, we could have very easily missed something, but since we kept it organized, kept a pattern going, we can quickly see here there's 3 in each column, there's 6 columns, so that leaves us with 18 possible passwords. Okay, our last option would be making a tree diagram. So that's what we're going to do on this last one. So if we read through it, a pizza shop has regular, deep dish, and thin crust pizza crust, 2 different cheeses, and 5 toppings. How many different 1 cheese, 1 topping pizzas can be ordered? Okay, so I know I have regular, deep dish, and thin crust. I have 2 cheeses and 5 toppings. So, making our tree diagram. Starting off with the crust. So we have regular. And it's important when you make a tree diagram that you kind of spread them out from the beginning because you don't know how large they're going to get. So we have regular. We have deep dish. And we have thin. Now, going with the regulars first. If you order a regular pizza, you have a choice of 2 different cheeses, so C1 and C2. Then once you pick your cheese, you then have a choice of 5 toppings. Now, it doesn't tell you what those toppings are, so we're just going to number them. So we have 1, 2, 3, 4, 5 for cheese 1. Then we have 1, 2, 3, 4, and 5 for cheese 2. Okay, now we're going to do the same thing with our deep dish. We can have cheese 1, or we can choose cheese 2. And then again, once you pick your cheese, you have a choice of 5 toppings. So again, just numbering them 1 through 5. And then we have that same option with our thin crust. So we have cheese 1, we have cheese 2, and again, 5 topping choices for each of those cheeses. And we just barely squeeze that in there. But, so if we count these up, because it's asking how many different pizzas can be ordered. So we have 5, 10, 15, 20, 25, 30 different pizzas. And if you wanted to know what they all were, you could just pick any one of the numbers below. So we picked, say, topping 4 with cheese 2 for our regular pizza. So you just follow it up the line. So you can see what all the 30 different pizzas are. Okay, so there is an example of making a table, making an organized list, and then making a tree diagram. Now, as you saw, these can take some time. Each of the questions just asked how many options there were. It didn't ask what the options actually were, but we had to list all the options in order to find how many. There's actually, if we go on to the next slide here, something called the fundamental counting principle, where if event M can occur in M ways and is followed by event N that can occur in N ways, then the event N followed by N can occur in M times N ways. I know that's a little wordy, but if we look at the example, it says if there are 4 possible sizes for fish tanks and 3 possible shapes, then there are 4 times 3 or 12 possible fish tanks. Now again, keep in mind, this isn't telling you what those 12 possibilities are. That's just giving you a quick way to find that there are 12 possibilities. So if we flip back here real quick, okay, I knew that there were 3 different pizza crusts, there were 2 different cheeses, and 5 toppings. So if I took 3 times 2 times 5, that would give us are 30 possibilities. So just a quicker way if it's asking you just how many possibilities there are, not specifically what the possibilities are. Now we can apply this to our probability. If we look at the spinner question here, Lamar is going to spin each spinner once. What is the probability that he will spin red and the number 9? So we want to figure out our simple probability first. So looking at this first spinner, what is the probability that he will spin a red? Well, if we look here, there's 1, 2, 3, 4, 5 different areas. One of them is red. So the probability that he spins red on that first spinner is 1/5. Think back to what we did with simple probability. And then what's the probability that he will land on the number 9? Well, there's 10 different areas. There's only 1 9. So the simple probability of that would be 1 out of 10. Now, what's the probability of both of them happening? If we go back and look at our fundamental counting principle, that tells us that we can multiply them. So 1/5 times 1/10 gives us a probability of 1/50. So what that tells us is that there are 50 different possibilities if we spin both of these spinners, and there's only one way that we can spin a red and a 9. So there is a 1/50th chance. Okay, so that's wrapping up this lesson. We have a couple practice problems here for you. So in questions 1 through 3, we want you to use any method to find the total number of outcomes in each situation. So you could make a table, a tree diagram, a list, or you could use that fundamental counting principle that we just talked about. And then 4 and 5 are more like the question that we just did, where it's actually talking about compound probability. So go ahead and pause the video, come back, and we'll go over the answers. All right, hopefully you guys actually pause the video. We'll go through these problems now. So number 1, find the number of tennis shoes available if they come in gray or white and are available in size 6, 7, or 8. Now, if you guys made a table, tree diagram, or organized list, you will hopefully get the same answer. Personally, I'm going to stick with the fundamental counting principle because I know it's a lot faster. So for this first one, there are 2 colors in 3 sizes. So if I just take 2 times 3, that tells me there are 6 possibilities. For number 2, the table shows the options a dealership offers for a car model. So there are 2 possibilities for the door. We have 2-door or 4-door. There are 3 possibilities for the gears. And then there are 4 possibilities for the color. So if we take 2 times 3 times 4, that gives us 24 possible cars. And then number 3, Elisa can take 6 different classes first period, 2 different classes second period, and 3 different classes third period. So we want to figure out how many different schedules could she end up with. So we have 6 possibilities for first period, times 2 possibilities for second period, times 3 possibilities for third period. So 6 times 2 times 3 gives us 36 possible schedules. Okay, I'm going to hop down to number 5 for a second. So a spinner with 8 equal sections labeled 1 through 8 is spun twice. What is the probability that it will land on 6 after the first spin and on 6 after the second spin? Okay, there's only one 6 because they're labeled 1 through 8. So our probability of landing on a 6 would be 1 out of 8 for the first spin times 1 out of 8 for that second spin, because we're trying to do the same thing again. Multiply them out to get 1/64. Okay, number 4 was kind of not necessarily a challenge question, but you had to think about it. So Amber has a denim and a black purse. Ebony has a black, a red, a denim, and a brown purse. Each girl picks a purse at random to bring to the mall. What is the probability the girls will bring the same color purse? Okay, if we look at Amber, she has denim and she has black. Ebony has black, red, denim, and brown. Now, if you notice, the denim and the black that Amber has, Ebony also has a black and a denim purse. So it actually does not matter which purse Amber picks. It all depends on what purse Ebony picks. So we have a 100% chance that Amber picks a correct purse, we'll say. So we could do, she has two possibilities for our denominator, and both of them are correct choices, so to speak, for your numerator. So 2 out of 2, you could have also just written 1. Times. Now, if Amber picks a denim purse, what is the probability that Ebony will also pick a denim purse? Well, she only has one denim purse, and she has 4 purses total. Now keep in mind, the same thing would be true if Amber had picked the black purse. Because again, it doesn't matter what purse Amber picks. So if I take 2 over 2 times 1/4, keeping in mind 2 over 2 is the same as 1. So 1 times 1/4, they have a 1 out of 4 chance of taking the same purse to the mall. Okay, so for that one, you had to realize that it didn't matter what purse Amber picked. We're really just looking at what Ebony was picking. Alright guys, that's the end of this lesson. So, if you have any questions, let me know. Make sure you're reviewing everything from the chapter for the upcoming test. If you have any questions on any of the previous lessons, don't be afraid to reach out about any of that either. And that's it.